Thank you very much for this presentation. It's interesting to see that even the Green Party in Finland is not opposed to nuclear, which is not the case everywhere in Europe.
Of course.
There's actually an additional, very delicious point to that is that both the City Council initiative and the Parliament initiative were co-written by a Green Party member.
Okay, I see. That's very interesting. So I have a few questions about the operational. So these are modeling results which are valuable, of course, but it's a modeling. Now, on the operational point of view, what do you see? Where should we put money to switch from innovation to the market? And what is the time delay you have in mind before being able to really implement these facilities?
It's
very quick. Please.
Yeah. Okay. Quick. Well, first we have to allow this technology. Nobody's going to have a project trying to build a district heating reactor if there is no regulation or legislation. So that's the first step. And now we have started taking that, which is great. And we are putting, in that sense, we are putting the money in the right place. What I would hope for more from the industry is to be a little bit more proactive in discussing with the public and the regulators and the legislations that they actually want to go ahead with these kind of proposals and projects seriously, so that the legislature knows that there is demand for this. Because if nobody's talking, then why should they do anything?
Thank you very much. So we will shift now to the ICT and numerical world. So the numerical technologies is already present in almost all areas of our public and private life, and it is expected to increase the electricity consumption from about 3,000 to 8 or 9,000 terawatt hour at the global scale by 2030. So digital companies are building data centers and developing new data centers infrastructure in all major electricity producing countries. How do they cooperate with the energy providers to reduce their carbon footprint?
First of all, there is a chance that not all of you know what EQUINIX is, so just to give kind of small perspective on that sense. In 2 sentences, EQUINIX is the world's largest global real estate investment trust, kind of focused to data centers only. We have 200 to 250 data centers globally. We operate in US, and South America, EMEA, APAC. So basically all the large developed continents. And you all probably know that, yeah, data centers are a big part of the general consumption of electricity. 2014, data centers were around 1% of world's energy consumption. Today, we are around 3%, and the chances are that we will reach 5% in upcoming years. So data centers, we are really kind of growing industry. In that sense, we are heavy power usage industry. But to understand where that comes, to kind of give you an answer, you need to know how the industry actually works. So why data centers are using a lot of power? Well, you have the devices, and all you guys, you have the devices here and tapping them now, right now. That's basically only part of the equation. I mean, there's 6 billion smartphones next year in the world. There's 20 billion IoT devices online on the world next year. So that's a huge amount. And all it comes down to data. So it's the data. It's not stored in the devices you have in your hands right now. It's very likely it's stored somewhere in a data center, which, I mean, cloud, but that's in essence, that's a data center somewhere. And how data centers then work? Why we need so much of power? Well, if you have 26 billion devices producing that data, And that's just the devices on a table and on your pocket. That doesn't count shipping, airborne, or nothing like that, which are also producing a lot more data on a table. So when you tap on the iPhone, check, this is my picture, I save it. It flows to your phone, flows to data center, where you have a huge amount of computers. We are talking halls wide of hundreds of meters that way, full of computers basically. And all those are running more or less efficiently, but they are running there. They are storing the bits and bytes you have on your phone. And they are drawing power. All that power, which is kind of used for storing that data, that in principle that turns to heat, which you need to cool down or reuse somewhere else. If you can't reuse, you need to use either a cold air, like here in Finland we are really good position. We can use a lot of year, almost 300 days on the year we can cool it basically based on cool outside air. But more south you go, less you can do that. And chances are that there's a more population in the southern part of the world than in the northern part. So partially you can serve stuff from north to south, but that's not, you can't do that forever because it's all about how close you are to the end user. So that means when you are more south, you need also use more power to cool down. It's kind of refrigerator. I mean, you need to pull energy to cool down the stuff you have in your data center. So that comes to energy efficiency. 10 years ago, you put the computer in a data center, draw kilowatt, and you need to put the kilowatt more to cool down that particular heat coming out of that server. And that's called power usage effectiveness. That's number two. You need to use 100% more power. So years come by, and now we are talking about if you have a new facility and you can really optimize it, you don't need to think at who and where it's been used. You can come as down as something like 1.1-ish if you are looking annual consumption. So meaning only 10% of excess energy needed for cooling that down. But that doesn't make any difference. That's still, you still produce more heat than you're actually drawing for computing power. Which means that there's a huge debate at the moment in the industry that how we should use that. Should that be kind of rewarded if data centers are reusing that heat? And as an industry, if you think energy, even though it's cheap in Finland and cheap in quite many countries present here, I think, excuse me, it's still one of the biggest, stuff is the biggest, energy is the second biggest part of your costs globally when you're running a data center. So there's a kind of built-in kind of target to reduce your energy consumption. But that doesn't help if you think, now we have 26, 20, 30 billion devices, it's going up quite rapidly. Even though we put a lot of money over the years that kind of increases the efficiency. As a company, EQUINIX has put in this decade more than 100 million just for replacing old equipment we have in the site, retrofit the stuff, plus building to more for the capacity which is needed globally. And we can do a lot of optimizing in a local level. I mean, globally, yes, buy less. Do more efficient ways, find more efficient ways to cool down the stuff. For example, in Amsterdam is the one example we are using, we are pulling down cool water down from the kind of underground, using that, cooling out the devices in the data center, and then pushing out the excess heat to the apartments around. In Helsinki, we have a kind of cooperation with the local energy company. They are cooling energy in the sea. It's pushed to the district heating system, circulated through our site here, and we are pushing back to the excess heat back to the network and it's therefore, again, used for heating to apartments. So there's a lot of ways we can kind of do and operate with the local communities, but nothing changes the fact that the data is increasing. We need to pull probably more energy. We need to be more efficient how we cool it, how we use it. And that also includes hardware manufacturers. I mean, there's a couple of different type of data center companies. I mean, saying data center in Finland, that's typically a kind of blank. Google, yes, Google has a one kind of data centers. Then companies like EQUINIX. The major difference is, if you are looking at Google kind of companies, they run stuff for themselves. They can optimize whole chain from the beginning to end, including the hardware in a data center, and optimize it, including energy producing, because they can be located anywhere they want to. That's the one way. They optimize, they can do a lot. Then, companies like us, we are more or less hotel for the servers. We are providing the environment, security, cooling, power, connectivity, which is really, really important part of the business. We are really much reliant what the energy sources are available on the area, because we need to be there where the market is, where the customers are. We need to be close to customers. We need to be compliant with standards which customers are using. We need to be able to accommodate the servers customers are using. So there's a lot of kind of networks around we need to comply with in order to be more efficient. Did that answer your question?
Yeah, I think so. Thank you very much for this enlightening
Il nous reste 10
information.
minutes. 10 minutes.
Okay, so we have to move on to the next question. Electro-intensive industries need competitive energy, and at the same time they need to reduce their carbon footprint, of course. So Finland has some innovative solution in this direction, and a type of original contractual relationship between industrial groups and electricity supplier, like the one you are in charge of. Can you tell us a bit more about this original solutions, please?
Okay. Thank you for being invited here. So that, coming from a company called Pohjolan Voima, and we are 76 years old company, and we were established right after the second world. Yeah. So we were. Can they hear from there? Yes. Okay. So we were established right after the Second World War, and it was a very big lack of capital at that time, as we can assume. 8 big industrial players in this country put forces together and established Pohjolan Voima. And through this setup, we were able to build a hydropower plant up north, which was, capacity of 200 megawatts. So without having this kind of a setup, that would have not been possible. So 76 years we have produced energy here. Nowadays, actually, through our assets, 20% of the electricity in Finland is produced through our owned assets. We are the major shareholder of Teollisuuden Voima, TVO, 60% of TVO shareholding. Then we have the hydropower plants, 7 of them, and then we have several combined heat and thermal plants located in the industrial sites, where we also produce, on top of electricity, we produce heat for the process needs, but also the district heating in the region. But through this setup, I guess you will hear from Juha Poikola tomorrow more about the Mankala model, as what mentioned already Rauli here. So this Mankala setup is just a very special thing. So through this setup, we produce energy to our shareholders. We have 23 shareholders at the moment, and we produce the energy through our own cost. So fixed costs are shared by the ownership shares, and then the moving costs are shared by the energy consumption. So that is the background. Nowadays, we have a big shareholders from pulp and paper industry. That's the major part. And we have also metal industry and also chemical industry. and nowadays also regional electrical distribution companies and also local company like Helsinki Energy. Helen is also one of our shareholders. So that is the setup. And through this setup, actually, we are now in the position that 90% of our power production is carbon neutral. So we have been building several biomass plants in this country. So telling that our private shareholders has been very keen of decreasing the carbon footprint already 20 years. So that's no new thing for us, which is very good thing. So this climate change is of course a big thing for our shareholders. Most of them have targets in their own strategy to be carbon neutral or even fossil free totally in their operations, and we play a big part there. After Olkiluoto 3 will be in force, so Pohjola Voima's electricity share will be 95% carbon neutral. So that is the direction. At the same time, the energy-intensive industry in this country has invested a lot of process improvements. There is a new pulp mill taken into use in this country 2 years ago, and now this pulp mill is actually energy positive. There is a 200 megawatts electricity production in the pulp mill, so there's a lot of process improvements done there. And clearly you can see that the pressure for moving forward here is even increasing, and not least coming from the investors. So big investors are after the carbon neutrality, and that is the thing. But basically, we Pohjola Voima here are pretty nicely located here. We have a hydro, we have a nuclear, we have a big share of biomass, and also our shareholders have a direct shares of solar, wind power as well in this country, and they are investing on the wind side. So that is the good. Because you have to remember that our global operating shareholders or customers, they are competing in the global market. And then it's of course important what we do in an EU level, but it's also important that what we do in the global level. It's a heavy capital intensive industries, and the transition does not happen in a fast track. But it will happen if we are not competitive producing the electricity also. And that's why maybe one last comment from my side. Didn't ask it from Massimo in the last panel, but it's a bit tricky now. Now there's discussions in the EU level that there is a sustainability financing model under construction. And if I have understood right, if we have understood right, there is a discussion that the nuclear power will be left out of this sustainable financing model, which is a bit hard to understand, at least in this context, that when we are fighting against the IPCC threat. So that, like stated, our shareholders are global players. So in the end, it will move in the environment or in the countries where all these elements are solved in a good way. But this Mankala-based Pohjola Voima has been a very good setup, and being on the market 76 years actually shows it that it has been a good setup to really get players building a large-scale nuclear plants even without managing the risk there, and without putting in all assets on the same back gasket, so to say.
Okay, thank you very much. I think we are in time, are we?